So we've done a basic introduction to vectors, and we'll just continue on with looking at two other examples that I had on the opening there, and they were the vector quantity velocity versus the scalar quantity speed. So as we said, that velocity has a magnitude and also has a direction, being a vector, and speed has magnitude only. So what we'll do is just have a look at a simple little example. This you'll need to be familiar with by the end of this unit. You'll be able to work all different scenarios with this situation. So what we're going to do is we'll look at the situation where we've got a boat, maybe not as fancy as that boat, and it will cross a river. So say this boat here is trying to get to, on the other side of the river, some sort of jetty, and we have a current that is flowing, if we say north is at the top, in a southerly direction. So this boat is endeavouring to, well, let's just look at firstly what happens. Say the boat just travels directly across. Now, if it travelled straight across towards the jetty on the other side, if there was no current, obviously it would land up at the jetty. But because we've got this current, it would actually push the boat off course, and the resultant would mean that the boat would end up travelling in that direction. So if you like, the boat would end up heading down this path because of the effect of the current. Now, what we can then say is that this is the velocity of the boat, and we'll get my pen tool back here, and this is the velocity of the boat, and because we've used the word velocity, we're implying that it has magnitude and direction, and for the moment we'll say that it is relative to the current. Here is my current, and it would be so many, with most nautical things they use knots, so it would be so many knots travelling in this direction. This would be the velocity of the current, and this would be the velocity of the boat. And it would be, if you like, the direction in which it would travel. So this is an example of using vectors to solve a situation here. This is looking specifically at the scenario where the boat actually heads towards the jetty on the other side, and because of the effect of the current, so these two vectors would give a resultant vector of travelling down in this direction down here. So we could say then, well, okay, what's going to be the best scenario if this boat, so we'll move our boat down here and we'll set up another scenario, and we've got the same jetty, and we want the boat to actually arrive at the jetty. So the boat, in fact, would not head straight for the jetty if we've got this current acting down in this direction. So the boat, in effect, would actually aim up in this direction, and the current would push it so that its net overall actual travel would be straight towards the jetty. So what would happen would be that the boat, even though it was aiming up in that direction and the current was pushing it down, the boat would end up, if you were standing on the shore, the boat would actually look like it was travelling straight towards the jetty. If you were at the wheel of the boat, you would actually be aiming up in this direction, knowing that the current would actually push you down. So this is an example, a scenario here of the use of vectors, and particularly velocity. Not only does it happen for boats, but for aircraft and navigation. Vectors are used to actually calculate flight paths. So when you've got strong currents or in boats and you've got strong airstreams with aeroplanes, and it allows people to be able to navigate and arrive at where they should be arriving using vectors.